You're looking at a custom-built DeepSpace Seeker 5 FPV drone. I've built this over the last couple of days, and in this video I'm going to show you what parts I chose, how I built it, and we're going to talk about whether or not this is a better option than buying the bind and fly version. And we're going to have a look at it flying and talk about some of the modifications I had to do to get it all working. So I'm going to use this DeepSpace Seeker 5-inch FPV frame coupled up to a set of 2306 2550 kV MEPS motors, a 60 amp SpeedyBee F405 version 4 stack. I'm going to be using the DJI O4 Air Unit Pro, but I'm going to be swapping the antennas out for these 150mm Fox Air Lollipop antennas. I'm going to use this micro air GPS that I've never used before, and that's going to need a custom housing. Finally, these are the props that came with the motors, and they're a colour that I'm obsessed with. DeepSpace is a fairly new company. I think so far they've released 4 drones. They've got a 5-inch, a 4-inch, there's a freestyle kind of thing, and they've just released a Cinewhoop. The frames come packaged in these nice neat boxes, and I'm not really sure why they include that tiny screwdriver, because you're going to need a lot more tools than that to build this drone. But you do get some of the nicest battery straps I've ever seen, as well as a sticky battery pad, a whole range of screws, more screws than you actually need. I had quite a lot left over. There's a bag of 3D printed TPU parts including feet, and there's a GPS cover for the top of the drone and some side panels which I didn't bother using. Like most other manufacturers, they include a couple of stickers, and there's also a set of instructions which are not very good. The next bag contains the arms, and we have 2 short ones and 2 long ones because I bought the dead cat version of the frame, although you can get this as a True X as well. The frame's available for an 03 or an 04 camera unit, and you get these aluminium machined front housings. I selected the 04 version, but as you can see from these mountings, I think you could probably fit an 03 in there. It seems to have both holes. The final bag contains the frame body, and you get 2 sandwich plates that go one above and below the arms. You get a top plate, and then there's a small front plate which is where you mount the GPS. Now, I said earlier that the instructions for this are not great. It's just a diagram and a parts list. It doesn't really tell you what screws to use for each section, what lengths to use. I also couldn't find the PDF on the website to actually download it, so all you're going to have to refer to is the sheet of paper. It's not that difficult though, so once you get everything in position kind of like this, you can start screwing it together, and I tried the 8mm screws first. But I soon discovered that these actually weren't long enough to go right through to the top section of the plate, so I started taking everything apart and used the 10mm screws. They did go through to the top plate, but I wasn't entirely happy with it, and later on I changed these out and swapped them all for the 12mm screws, which seemed to be perfect. Yeah, and you're probably all thinking, why didn't you just put it on the desk and measure the thickness of all the plates added together? But sometimes you just can't spot the obvious solution staring you in the face, can you? But now the frame's all put together, I can start thinking about components, and I'm going to start with this SpeedyBee stack. I've got SpeedyBee flight controllers in a lot of the drones that I've built. I really like them. They're nice and clean, easy to work with, and because they have Bluetooth, it just means that if you're out and about flying and you want to make some changes to your control settings, you can do that just by connecting through your phone app. And actually spend quite a lot of time trying to decide which way round to mount the ESC that you can see here, because the problem is the holes on the ESC for the capacitor are at the opposite end to where the holes are on the frame to mount the capacitor. So you would either need a capacitor with really long legs that can reach right under the ESC to the connectors, or rotate the ESC 180 degrees so that the battery cables can be connected with the capacitor. But the problem there would be running those 2 really thick cables underneath the ESC. They're not very flexible, and it would have meant raising up the ESC higher than I wanted to. So my solution was to use an XT30 cable, trim the plug off, and use the cables to run underneath the ESC. They're much more flexible. So the next step is just to trim down the legs on the capacitor, just down to a nice length so I can attach the cables, and then we can start soldering. I've also cut the end off the XT30 cable and then just put it all into position so I can measure the length of the cables and get them just right, before stripping the ends ready for soldering. And one thing I can tell you about soldering is that blue tack is your friend. It's just really handy for holding everything in position while you concentrate on the soldering iron and any tools that you need to hold your wires in place. I only started soldering last year, and this is a really cheap Amazon soldering iron, and I don't claim to be the best solderer, but I've never had any problems with it. And that's the capacitor in place. Next I need to connect those cables to the underneath of the ESC, so I am just going to apply some flux to the 2 pads. I prefer to use this flux that comes in a syringe, I just find it convenient for putting it in place. And then pre-tinning the pads ready for connecting the cables. And I did warn you that I am not the best solderer in the world, so if you are good at soldering and you're watching this and your eyes are hurting, I am sorry about that. So once again, I'll just remind you that blue tack is your friend when it comes to soldering, and as you can see here, I'm holding everything in place with lumps of blue tack before using a pair of pliers to hold the cable in place, heating the solder and the end of the cable to make the connection. However, I did have to remove this solder because I'd forgotten to put heat shrink on the capacitor end of the cable where there's slightly exposed connections. And after that, I put it all back together with the blue tack and soldered it for the final time. If you do use this blue tack method, the blue tack can get very hot and soft, but it's easy to remove afterwards by just getting another lump and dabbing it against any components that have got blue tack stuck to them. So now I'm just putting the ESC back in place and seeing how everything fits, and trying the flight controller on top as well. The flight controller came with some plastic nuts, and I used some of them as spacers on top of the frame to raise the ESC up to run the cable underneath, but they raised it too high. So I made some simple 3D printed washers, removed the plastic nuts from underneath the ESC and replaced them with my own 3D printed washers. Then put it all back together, but this time I've included the ESC cable because it's in an awkward spot to put it in afterwards. And I'm happy with that. The only part I'm not entirely happy with is there's no space at the front end of this drone for the buzzer that I usually use on these builds. I would normally mount it in the cavity that sits behind the camera, but because I've put the capacitor in that space on this build, there's no space to put the buzzer in. However, I might modify this later by bending the capacitor upwards to make space. And now that I'm happy with all the base electronics, I'm just changing those 10mm screws in the frame for 12mm screws, before adding some more of the hardware like the standoffs and the front end machined aluminium camera mounts. So now we can start thinking about motors, and I actually bought these about 6 months ago on AliExpress. I have a bit of an obsession, as you can see from this photo, with this colour scheme on my drones, and so when I saw these I just couldn't resist. And I'm going to screw the first one into place and get all the wires to the right length. And although I do the motors one at a time, I am going to tin all of the pads on the ESC, but not before I've put some flux on each one of them to make sure I get a good connection. And another trick that I do with my solder is to bend it so that you can get it just into the right place where you want it to go. By my usual standards, I say I've done a pretty good job there. So the final step before actually soldering these down is just measuring the length of the wire to get it perfect, trimming it off, stripping the ends, and then threading the motor wires through the self-adhesive plastic tubes that come with the drone, and press them firmly into place on the arm. Now we can pre-tin all of the cables that are going to be soldered to the ESC. As always, I'm using a blue tack sausage just to keep all the wires in place before I solder them. I just find this the easiest way to do it. You might disagree, let me know in the comments if that's the case, and we can have an argument about it. So that's the first motor done, and as I've said before, I'm not the best solderer in the world, but as far as my standards go, that's pretty good. So that's all 4 motors in place, and while I'm happy with the solders, I think I could have done a better job of measuring the wires, but it's not bad, I'm happy with it. So now I'm going to move on to soldering the battery cable on and positioning it on the drone. And if you've ever worked with an XT60 cable, you're going to know that they're pretty thick, difficult to solder, they're not very flexible, they're not very forgiving. So I have to be quite methodical about this, and the first thing I'm going to do is take the XT60 connector that came with the drone frame and connect it using the screws that came with it into the top of the frame. I'm also going to pre-tin it with quite a lot of solder because it's a really important connection. I'm going to be running this drone on 6S batteries, so there's quite a lot of power going to go through this, and it took me a couple of goes to get it right. Here's the positive going into place before cutting the plug off and it took me a couple of goes to get the negative into place, but eventually I was happy enough with it. Let me know in the comments what you think of my soldering, but you know, please be polite. And now that I'm happy with the length of the cables all trimmed up, I just need to tin them, ready for final soldering onto the battery pads. But here's one area where I definitely need to improve, and I would probably benefit from using a much bigger tip to do big connections like this. And if you're enjoying this video, or even if you're just completely horrified by my soldering, you know, maybe you should give me a like or subscribe to the channel, and it might encourage me to try harder next time. Now you might be wondering how I'm going to fit the DJI O4 Air Unit Pro onto that space at the back with those big thick cables in the way. So this is why I am now designing a riser to allow a channel to run the cables underneath the O4 Air Unit. And with the magic of 3D printing, we end up with something that looks like this. And that'll fit perfectly into place to run the cables underneath the O4 Air Unit. I designed it with two sets of holes. The smaller inner ones are to lock it onto the frame to hold it in position while you attach the air unit using the bigger holes. So let's open this up and have a look at it. If any of you have used the O4 Air Unit before, you'll know that there's just no need to use an action camera anymore. The 4K quality from it is beautiful. It's got built-in stabilisation, or you can switch that off and use something like GyroFlow afterwards if you want to. I just need to open this one up so that I can attach these 150mm fox ear antennas. It's debatable whether these actually do give you any improvements. I couldn't argue really honestly either way, but I just feel like if you've got some antenna sticking up above the battery when you've got it all put together, maybe you just get some better reception. I don't know for sure. So after connecting these back into the DJI O4 Air Unit, I did have the good sense to take some measurements before finding screws to hold the O4 into place. Now, as I mentioned earlier, this frame kit does come with some TPU parts. One of them you see here for mounting the antennas on the back end of the frame. But one area where I think that DeepSpace could improve is putting these onto the website so that you can download them and modify them if you want to. I'm quite proficient when it comes to CAD and 3D printing, and I was probably being a little bit lazy, but these fox ear antennas wouldn't fit properly into the holes that are designed for O3 because the fox ear ones are slightly thicker. So it took me quite a lot of manipulation to get them into place. But I got there in the end. So we're getting closer to the finish line with this, and now I'm going to start putting in place some of the stuff for the front end, including this TPU underguard and a set of silicon inserts that are for mounting the DJI O4 camera, before securing the camera in place. Now, the digital cable that came with the DJI O4 Pro was a bit long, well, way too long, so I've just swapped it out for a shorter version, about 5cm long. And now I'm just going to connect the O4 Air Unit and the ESC to the flight controller and put it into place. I've actually ended up with the whole stack sitting a bit too high. There was no room to get the nuts on, so I've had to tighten them down too much, and that's caused a problem that we'll come back to later. But at this stage it's a good opportunity to test the whole setup with a battery and a smoke stopper. So here we go. That all sounds good to me, so let's move on to doing some CAD to make a custom housing for the GPS unit. And let's 3D print it in TPU. So this is the GPS I'm going to use. It's a Microware GPS. I've never used one of these before. That's the 3D printed mount. And once the main top plate's in place, there's a smaller one that goes in front of it, and that's where the GPS is going to sit. So I'm going to plug the cable into the GPS. It's going to be way too long, so we'll have to trim that down later, but that's about where it's going to sit. So let's screw down the plate and the GPS canopy. and then thread through the GPS cable and sit the GPS in place so I can measure and cut the wires to length. I should also mention that the way I designed this canopy for the GPS made it very difficult to actually get the GPS unit in, so I had to cut a small slit just to add a little bit of flexibility so I could get the actual GPS unit to fit in. But then I've used my snips to cut the plug off the other end of the cable, and I think I need to order some new snips because these are obviously blunt. Then I've just twisted the wires round and put a piece of blue heat shrink on there before using the heat gun to make it all contract into place, which is always very satisfying to watch. I keep saying we're nearly at the end, but we really are nearly at the end now. I'm just cutting off the excess wire here for the GPS and then stripping the ends ready for tinning and soldering. Now these pads for the GPS are very small, so I'm going to put some flux on them first of all using the syringe. It's always a good idea to try and be as methodical as possible with tiny wires. So first of all I'm just tinning the two pads furthest back. I don't want to do the front pads yet because there's a chance that I might accidentally desolder the back pads if I try to do them all at once. So now the pads are tinned, I can separate all the wires ready for tinning those, and carefully go around and just add a little bit of solder to the end of each one. Then it's time for the blue tack sausage again, before putting the tiny wires close up to the tinned pads and making the connection. And now I'm repeating the whole process for the front row of 4 pads, tinning each one before moving the blue tack sausage and soldering each of the 4 wires in place. Did I mention we're getting near to the end now? Well, just securing the GPS cable and then going through the process of putting the last few plates back into place, tightening everything up, getting ready to configure this drone. So here comes the sticky battery pad, the final 2 screws to hold the XT60 connector in place, and this is what it looks like, pretty much finished. Except I've not put the battery straps or propellers on yet. Now we need to do some configuration, so in BetaFlight I'm just going to quickly whiz through what I do. First thing, just making sure the accelerometer is reset and check that it's going in the right direction when you move it around. Then we'll go and have a look at some of the ports, and with this flight controller I've got the GPS on UART6, UART4 is Bluetooth, UART1 is going to be my DJI O4, and because I'm using a DJI controller that will be on UART2. So let's have a look at the GPS, and you can see by the light in the top of the panel that my soldering was a success, and we are starting to get some satellites even though we're just sat on my desk. So I'm going to switch on Galileo because I'm in Europe, and although I don't know what ground assistance actually does, I always switch it to Europe. And then I've just gone back to the ports tab and make sure that everything is properly set up. Next I've gone to the receiver tab just to make sure I'm all set up for DJI's controller, and because I'm using that I'm going to go into the CLI and type in set SBus board fast equals on and then save. And if you're using a DJI controller you will also need to, inside the goggles, you need to go to the controller settings and make sure SBus board fast is also set on in your goggles. Next is the configuration tab, and although I do use air mode when I'm in acro mode, I don't have it on all the time, and I also switch on the 2 beepers for when RX is disconnected. Next, in my battery settings, I change the maximum cell voltage to 4.35. This is to prevent any false warnings of low battery when you first connect. Now in the presets tab, I'm going to go and put the OSD on for DJI, and I accidentally selected UART4 when I was doing this, but I did go back and correct it later to UART1. Now on the PID tuning tab, I'm not going to do anything with the PID tuning. All I'm going to do is set my rates, which I set to 0.25 expo and 600 maximum rate, and that's for pitch, roll and yaw. And then for my throttle, I put 0.25 expo on that as well. Now my modes, I use 4 things on my remote. I've got arm, angle mode, I've got the beeper, I've got air mode, and I've got flip over after crash. Now you might have noticed that I said I've got 4 things on my remote and then I listed 5. That's because I only use air mode when I'm in acro mode. I don't have air mode on when I'm in angle mode, and what you're looking at right now is the way I set this up. Now while I've been setting those modes up, the GPS has been happily gathering satellites. So next I'm going to sort out my OSD. There are lots of ways to do this, and this is the way I do mine, but this is how it looks when it's finished. Now moving on to motors, and I like my propellers going outwards. I just feel that if I was to hit any twigs or anything like that, I'd rather have them forced out to the side rather than inwards towards the camera. Now with all the propellers removed, I'm just going to quickly test the motors, and first of all with the master just to see they all spin, and then one at a time just to check the direction with a piece of paper against the top of the motor. And I discovered that all of my motors are going in the wrong direction, so I'm going to have to reverse them using escconfigurator.com. And if you've never used this, you just disconnect from BetaFlight, then click on the connect button up at the top of the ESC configurator website. Then click on the read settings button at the bottom right, and that will give you all the settings for your ESC, where you'll see that mine are all set to BL Heli, but I want to use BlueJ. So next I'm going to go to the bottom and click on Flash ESCs and change the settings to BlueJ. Leave that ESC preset it is, change the version to 19.2, the PWM frequency to 48, and then click Flash to flash all the ESCs. When it's done, I'm going to reverse all the direction, then go to the bottom and click on Write Settings. That'll only take a minute, and when it's finished you can click on Read Settings to just make sure that everything's worked. And if you're happy, just disconnect and go back to BetaFlight and the Motors tab. Now I'm going to switch on Bidirectional D-Shot, then save and reboot. Then we can do another test on the motors, still with the propellers off. If you're happy with the direction, then we can go and put the propellers on. There's one thing to do before that though. I mentioned earlier I'd forgotten to put the battery straps in, so I've just loosened the top plate and slipped them in and tightened everything back up again. So this is looking really nice. And from the photo I showed you earlier, you know that I've got that obsession with that colour scheme, so when I saw these I just had to have them. Motors, propellers, bright green. And now I'm going to show you the easy way to remember which way to put your propellers every time. The fat side always goes up. When I say fat, I'm talking about convex, and if you know the difference between convex and concave, the side that's bulging outwards is always facing up, and that doesn't matter whether you're building a whoop or an open prop drone. Then you've got a leading edge, which is the thick edge. That's the direction that's going to be cutting the air, and the thin edge of the propeller is going to be the trailing edge. So that means these propellers are going to go this way round. And now that we know that, we can put them all in place and bolt them down nice and tight. I bought this new tool, which I was hoping would help me with my disability in my hands to tighten the nuts down, but I really struggled with it and ended up reverting back to my little wrench. So let's go outside in the garden and do a quick flight test. So as you can see, I'm not having much luck here, and there's a couple of reasons why. Although I did end up getting a smooth takeoff, part of the problem is that the disability in my hands makes the controller vibrate, and that gets exaggerated by the fact that I tightened down the flight controller too tightly. And this is what I've come up with as a solution. So basically it's a small kind of bridge that replaces the 4 nuts that are on top of the flight controller. This is what it looks like when it's printed. So very quick disassembly, and we'll put these 2 new bridges in place. They're going to put much less pressure on the flight controller than the 4 nuts did, but still keep it firmly in place, and hopefully less vibrations will get through to the gyro in the flight controller. And then we can put it all back together and go and have a fly in the park. Okay, so I lied about the park. This is actually the local flight club. We've got a really good location near us where they've got a motocross track, a jet ski lake and a flight club all right next to each other. And we sometimes go chasing jet skis and motocrossers. But the flight club here is a perfect place to go and do a shakedown. Just go and fly up and down and try out your new build. So at the start of the video, I said we'd discuss whether or not this is as good as the Bind and Fly or better. And it's really hard to say because obviously I've not bought the Bind and Fly. But what I can tell you about this is it's punchy, it's powerful, it covers ground really quickly. It's agile in the air, and the main thing is I built it myself and you can't put a price on that. If you enjoy flying drones, I would always say to people that building one is the best way to do it because you learn so much about what's inside it and how to make repairs when you need to. And finally, before I leave this video to play out with some music, if you appreciate what I've done here, please give it a like and consider subscribing to the channel.